We can use this idea of impulse to change the way objects interact with each other. For example, if we want a situation where we need to reduce the amount of maximum force of an interaction, we can change the amount of time that interaction occurs. Thinking about catching a baseball. Have you ever tried to catch a baseball with just your hand? It's probably not long after that interaction that you had gone and found a mitt. Why? The mitt allows for your hand to move backwards during the catch. When you do that, you reduce the large amount of force being transferred to your hand because you're increasing the amount of time for that interaction. Same principle applies to bungee jumping. Why don't you use just a regular rope as opposed to a stretchy cord? Your joints can't handle that. So if you were to use a rope for your bungee jump, you would come to a very abrupt stop and be very sad. So the opposite also is true. If we want to deliver the maximum amount of force during an interaction, we would need to decrease the amount of time. Examples are going to be things like boxing and karate. How is someone able to apply enough force to a wooden block to break it in two? Now, there is a technique involved, but the secret really is hitting the block with a really fast jab so that the force is maximized. Now, we can apply these things in other situations as well. When we look at cars, we hear a lot of times that they don't make them like they used to. 20 years ago, if you were to get into an accident, your car would not have looked like this. You probably would have been able to repair it. But the thing is, what is happening to this car? Why was there so much damage to the front end of the car? So this is called a crumple zone, and this is a safety feature. And it applies that idea of impulse. If you increase the amount of time of the interaction, the force applied becomes less. And it becomes less for the people inside. So if you look at this vehicle right here, what do you think the inside looks like? What do you think happened to the people inside? So here's a picture of the inside after the accident, and you can't even tell. That's the purpose of a crumple zone. It's so that there's damage to the car, but not to you. So how can we represent this mathematically? When we find that area under the graph, we are actually multiplying the force being applied times the time. This lets us write a mathematical equation for impulse. In this equation, F is the force that is being applied, and we are going to measure that in newtons. T is time, and it's measured in seconds. Impulse is represented with a J. Nobody really knows why, but it is. Since we are multiplying force times time, we get a label of newtons seconds. Be really careful with this one. This is not newtons per second, but newtons times seconds. So as an example, what is the impulse experienced by a shopping cart that is pushed with a net force of 100 newtons for 2 seconds? Now we know from this particular problem that the net force is 100 newtons, and we know that the time is 2 seconds. It might be helpful in these to sketch out a force time graph. So we would have force on our y-axis with 100 newtons, and we have time on our x-axis with 2 seconds. That gives us that equation then of the net force times the time equal to the impulse. So our net force is 100 and our time is 2 seconds. So our impulse is 200 Newton seconds. All right, now that you've gone through that, can you define impulse? And can you use a force time graph to determine the impulse delivered to an object?